Hello everyone, welcome here. This semester's Colloquium. I think that's the only one we have this fall. So I am absolutely delighted to present here Professor Jillian Scudder. She gave a bullet lecture yesterday to Greg Watt. It was a great success as far as I was concerned. And not only that, she wrote two books. So this is partly on how to turn your science into a story back. I'm really curious about that. For the background, Jillian got her PhD at the University of Victoria, which I now remember because I forgot on stage yesterday, and then did a postdoc in Sussex, and after that was a professor. Started as a professor in Oberlin and has been there for the last 7 years.
Yeah, since year 7.
Wow. Okay, you just started. Yeah. Okay. So I've seen her teach, I've seen her talk. It's awesome. So I'm really excited to go back. All right.
Alrighty. I will do my best to be loud for you people because I'm very, very bad. So yes, when I was invited to give the bullet lecture, I was also invited to give a talk on basically how I approach the process of going from science to something more like a story. And this is a thing that I've done a couple of times where I talk about very scientific things, but I'm aiming it at a general audience. So all of my books are aimed at someone who does not have an astronomical background, but who might be interested in it. And so there is some translation that has to occur between, like, hey, I want to talk about something astronomical, and hey, I have a reasonable way of doing that. So we'll start with the science and get to the story. And the science piece is, this is where most of us have actual training. So as an undergraduate or a graduate, our training as a graduate student, our training as scientists happens in a relatively formalized setup. So we have, as undergraduates, we have classes, we might get involved in research, we have exams, we have voluntold class participation, we have things where we can get a little bit of experience with trying to do presentations, things like that. As a graduate student, we get more into research, and so this whole thing of science is a relatively formal, like the training as scientists goes through a relatively formal process. And as graduate students in particular, we're being trained in how to do careful research and how to write technical papers. And even as an undergraduate, a lot of what we set up for is things that are aiming us towards those skills, even if they are not aimed at them directly. So we might have a lab class, and that's not strictly telling us how to do novel research, but it is getting us towards the sense of like, okay, well, here's an experiment. How do you annotate that experiment for yourself? What do you need to see from yourself for future self so that when you look back and say, hey, what did past self do, you have a better sense of what it was. And so that is a skill that goes into research. Generally speaking, though, as scientists, the end goal of any particular research project is the peer-reviewed journal article, which looks like this. And I'm dunking on my own paper here, which I'm declaring to be legal because it's mine. So this is an abstract from my most recent paper, and that's a lot of words. It's dense. And among the density, which I'm not going to ask you to read right now, this is a convention in astronomy that we write in a relatively formal manner. So it's not necessarily in the passive voice, but it is in a relatively formal and structured type of language. And so by convention, we also have a relatively dense information structure. So this again is one of my own papers, and here we have the 2-column format. We have, in this particular page, 2 tables, 2 columns of text, captions on those tables, actual text, references to other work, references to figures, references to appendices. There is a lot happening in one page. and this is not intensely digestible if you have not had the training and the relative expertise in this area. So if you are working with this, really this paper is being written with a very specific audience in mind, and it's other experts. It's not even necessarily a graduate student in the field. It is people who already have a lot of knowledge and a lot of background information. So the audience here is very particular. On top of all of this density and the formality of the language, there are a lot of syntactical and grammatical rules. So these are the Munro's Style Guide for authors. So this is monthly notices of the Royal Astronomical Society. These are detailed instructions on how to use punctuation in your paper, whether you get to use a hyphen, an N dash, or an M dash. How long can your hyphen be? In this particular one, it's like, oh yeah, you can use an N dash, but only in specific circumstances. Never get to use an M dash. And then the hyphens only happen in other specific circumstances. And that's just the hyphens. Then we have spelling and grammar, which this is a British journal, so in general we have British spelling, except for recognize, criticize, minimize, emphasize, organize, ionize, polarize, and parameterize. So not only are we prescribing the format of the page and the technicality of the language, we're also having rules put in place for how we spell words, how we hyphenate words. We've got data is a plural word, none is a singular word, like our grammar is being prescribed here. That's not even all of it, there's more. This is how to do the units. If you're gonna write down the units on your page, you get to say, all right, well, yeah, you can't use a superscript for minus, you can't use a slash for kilometers per second, you have to use the superscript up to the power of -1. And also in here is my absolute least favorite rule for Munro's of all time, which is that percent can't be written as a percent symbol, it has to be written as 2 words per and cent. I hate this rule, and therefore I do it very, very last. I write it the way I want to, and then I find and replace all of my percent symbols and all of my percents as 1 word right at the very end. So the reason I'm showing you all of these things in my own papers is to give you a sense of how specific this type of writing is. This is a very, very specific genre of writing. And so it makes sense that in order to be able to write one of these papers, it is going to take training, it is going to take mentorship, it is going to take guidance, it's going to take repetition, it's going to take time to learn how to do this. Because there are so many rules, and the guidelines are so strict, and the expectations are so specific, that it's not something that I could hand to any particular student and then go, hey, write one of these, please. It's not a thing I can give as an assignment, be like, hey, just churn one of these out. Here's the rules, you can do it. This is a thing that does require attention and training and guidance and repetition. So, when I was a graduate student myself, I discovered something rather unfortunate, which is that I can actually find this type of writing incredibly fun. It's a necessary form of writing, but it wasn't entertaining. I wasn't having a great time about it, which is totally fine. And at this point in my career, I am completely okay with that. It is totally fine to me that not everything I do is enjoyed the same amount. There are parts of my job that are necessary, but which I don't find particularly fun, and there are parts of my job that are necessary that I find extremely fun. And on the whole, I wind up enjoying my job, and so this is a piece of what I do, but that I don't find intensely fun. On the other hand, this fact that I don't find it incredibly fun is valuable information to me, because what it does is tell me that I can start asking myself more questions. I can start figuring out, okay, well, if this isn't fun, what is? So the actual question that I wrote to myself was, how can I make writing about science more fun for myself. So I've articulated that the peer-reviewed journal article isn't it. And I've also articulated that I do in fact desire to have fun while writing about science. And so from here I have a thing that I can work on and a thing that I can push towards. So the step one that I worked on was, okay, well if that genre of writing is not very fun, but it's not the writing that's the problem, let's try some other genre of writing, some other way of talking about science and writing about science. And so I started out with a blog, which I called Astroquizzical. And this, I started, one, because it was easy, and two, because it was 2013, and everybody was starting a blog, and it was like an easy and good thing to do at that moment in the internet. So Astroquizzical came up as a name because I was doing a question and answer, so I was having people write into me with questions, and then I was doing my best to explain the answers as best as I could. Other bonuses of this is that I could write however I wanted to write. It's a blog. No one is assessing this blog for technical rigor. And because it was started out of a feeling of rebelliousness against the technical paper, this meant that I very specifically wanted to avoid what I was considering to be dry prose. So I wanted to escape this like very formal way of writing and do something else, do something different that I found more entertaining. On the other hand, knowing what you don't like doing is not the same as knowing what you do like doing. And so me sitting there being like, I do not want to write a technical paper. There is a huge volume of other options. Where else can I go? Literally anywhere. The technical paper is such a specific and kind of extreme end of technicality and denseness and very jargon-filled and dense paper writing that anything else is going to feel a little different from that. And so what I landed on was that I wanted my writing to sound like you were having a chat with a friend. It wasn't meant to be formal, it was meant to be accessible, it was meant to be like, hey, I have a question and you probably know this, please explain. Or like, hey, you know things about this, what is this about? I wanted it to have that kind of mood to it. So that meant I had stumbled into storytelling as a mode. Because when you are talking with friends, unless you are talking about something incredibly tedious, like the Electoral College, stories that you tell friends generally have a lot of pieces to them. So it's not just that you're telling the story in just the facts and only the facts, like nothing else is important to the story. No, we come in and we got metaphors, we've got jokes, we've got connections to other experiences, maybe callbacks to other things that we've talked about last week or this morning. And then at some point you're going to stop. So we have a natural end point. We have this riffing, kind of informal sounding back and forth, and then we have a natural end point. So this is actually not that far away from what we consider traditional storytelling. So in your traditional story, we have a few basic steps. So if you boil stories down to their most fundamental levels, you have a protagonist who is your main character. The protagonist has a problem. In your story, at the beginning of your story, often this problem is situational, or something has happened to them that is beyond their control, so that they have a problem nonetheless. They are then going to take some action to resolve that problem, encounter some new problem. This is usually your peak of your story, and then they're going to overcome that problem and come to some resolution. That's the basic story. You have a protagonist that has an issue, they're going to take some action, they're going to encounter a new problem, they're going to do another action, they're going to come to a conclusion. You can make this story much longer just by encountering more problems. So at that point, you now have a much more complicated story. You have a protagonist, and they take some action, and they find a new problem, and then they try to fix that problem, and they find something else that's in their way. And then they have to take another action to get around from then there's a new problem, and then eventually, by the end of your story, they have come to a resolution and they have hopefully solved all of their problems, or at least all of the ones that they want to feel like fixing that day. So this, the very basic storyline model, when I was writing this talk for my Python, we've done this one before. There was an old lady who swallowed a fly. I don't know why. Perhaps she'll die. This whole thing, there was an old lady who swallowed a spider that wriggled and jiggled and tickled inside her. She swallowed the spider to catch the fly. I don't know why she swallowed a fly. Perhaps she'll die. This is exactly the same cadence, right? We had a problem, which is that you swallowed a fly. We don't know why. And then you take some action to resolve that problem. In this case, we're going to swallow a spider. But then it keeps going. And so then you get to, there was an old lady who swallowed a cow. I don't know how she swallowed the cow. She swallowed the cow to catch the goat. She swallowed the goat to catch the dog. She swallowed the dog to catch the cat. She swallowed the cat to catch the bird. She swallowed the bird to catch the spider that wriggled and jiggled and tickled inside her. She swallowed the spider to catch the fly. I don't know why she swallowed the fly. Perhaps she'll die. This is exactly the same storyline. Of course, this particular one does come to a natural end because the last lines are, there was an old lady who swallowed a horse. She died, of course. And that's your solution. So our resolution isn't necessarily a happy one, but there is a resolution. And we did have a series of actions that took us to our resolution. And so depending on what kind of story you're reading, if you're reading old-time fairy tales, often there is a kind of happy ever after solution. If you're reading old Japanese fairy tales, often the solution is, and then everyone died. And if you're reading some kind of story that is more involved than that, then usually there's kind of like, oh, and then I understood something. And so that is your resolution. That's your end point of your story. And so if you're chatting with a friend about something, it's usually like what happened, and then you either reach the end of the story or you figure out the thing that you were asking them to explain to you. And then that's the end and your resolution of your story. So, the fun part is that you can make a story out of anything you want. And that includes the technical paper. It doesn't have to be some fictional character that's off swallowing horses. It doesn't have to be a fairy tale. It can be literally anything that you would like to communicate about. And so this includes the technical paper in this thing. I have a build error on the next slide, so you'll have to forgive me. The structure of storytelling, though, is not that different from the structure that we have for doing or reading about science. So we start with, you have a problem. And that problem is probably that you don't understand something. You're going to take some action, which is going to be sitting down and figuring it out. You're going to encounter a new problem, and the new problem is almost definitely going to be, it wasn't that straightforward. Whatever it was that you were trying to figure out had some complexity to it that wasn't appreciated when you started. And so this will be confusing. That will be your new problem. And then you're going to come to a resolution, which really in scientific terms is going to be coming to an understanding. You will figure out the thing that was confusing you, and that is kind of your end point of your story. We do see that this can be done both for doing research in terms of like, hi, I personally do not understand how this works, and I am going to sit down and figure it out. And it also works for reading about someone else's science. Like, I'm going to sit down and figure out what they did, because at this moment, I do not understand what they did. And so then I can sit down and read their paper, and I can get confused in the middle of it, and then I can figure it out, hopefully by the end of the paper. Or I'm going to wind up emailing somebody, be like, hey, I don't understand this at all. At which point I've just encountered a new problem, but then my action is to send an email about it, and then I will hopefully figure out the answer. If we're going to do this, though, we do have to actually start with the technical paper. So our goal here is basically to start with this, the technical paper, and get to a story that you can tell other people. And depending on who you're telling, the story will be different. And so at this point, this might just feel like magic has to happen at the mystery stage 2. That we go from a technical paper to a story. But as with all things that seem like they should be magic, this is actually just a combination of technical understanding and skill. And this is where we can start to pick apart things and figure out what's going on. So with technical understanding, this is where our formal training as scientists comes into play. This is where the formal training of, okay, well, you've taken classes, you have background information. Because technical understanding in this concept is really just, it's a body of knowledge. It's the things that you already know. It's the skill of being able to read and learn from papers, which you will need even if you are doing your own research or if you are reading someone else's paper. It is also the skill of being able to identify gaps in your own knowledge. So in that case, you have to be able to sit there and be like, actually, I don't understand this. There's a leap. I know that we go from here to here, but I don't understand how. That is a skill in and of itself. So these skills and the body of knowledge that we would like to get through, these are things that we get through research practices. So if you are working as a scientist, these are all things that I need to have anyways. I need to have a body of knowledge to be able to write my own papers. I need to have the ability to read other papers and learn from other papers to inform what my science should look like. I need to be able to figure out when I don't know something and I need to go to somebody else. So all of these things are things that come as part of our training as scientists. So our formal training comes in really handy for this technical skill piece, for the technical understanding piece. For the skill half of it, this is where aspirations come in really helpful. Because skill is something that you just repeatedly do until you are good at it. And so the aspiration that you need is the desire to become good at it. And in order to get there, you're going to have to write stuff that isn't good. And then you can write stuff that's kind of good. And hopefully all along you can be writing stuff that's fun, so that you're enjoying your way towards proficiency. And so all of this is basically just practice. All skills are practice. If you want to get good at art, you gotta practice. If you want to get good at music, you gotta practice. Good at math problems, practice. Writing, also practice. And so if you want to have the skill of translating from paper to a story, this also requires practice. How much storytelling you're going to be doing depends on the kind of writing that you're doing and what you're trying to do. So if I'm trying to tell a singular story, I have my one gold star sticker story that I would like to tell. This is the sort of thing that you will do. You have a coherent story. If you are writing something like a blog post or a news article or a social media post of any kind where a thing has occurred or a question has been turned into you, or you want to communicate a singular idea, then you have a story to tell. There are also situations in which you might find yourself writing 35 consecutive stories. And there you have written a book. So books and complex stories can either be a sort of string of stories, one after each other, or they can be a set of stories kind of in parallel to each other. It depends on the kind of thing that you're trying to tell. It depends on the kind of story you're trying to tell. So for a very complex novel, for instance, you might have like 2 or 3 storylines going in parallel, but then each of those storylines themselves is quite elaborate. You might have one extremely long narrative that takes you through a whole book. Or in the case of my most recent book, it is actually just 35 chapters of different stories happening. So you can also have just 35 short stories attached to each other. It really depends on what you're trying to do. So how you do this, and like how that storytelling structure plays out really depends quite strongly on what your goal is. What are you trying to write? Anchoring your paper, or your writing, whatever it is, in the technical paper can be challenging because it requires a lot of papers to read. On the other hand, I checked my most recent book, and I have 44 pages of citations for 194 pages of book. And this is anchor everything I wrote in a technical paper. So anything that was like, oh, yeah, if this were in a technical paper, I would cite here. I just cited there. Like, oh, here's an interesting fact. Here's where I got it from. Here's another interesting fact. Here's where I got that. Here's a thing that I learned from somewhere. Here's where I learned it from. And so as you're reading through it, the citations are not going to be super apparent to you, but then if you're curious about it, you can flip to the back and there's a citation for almost everything in there. So this is a very particular form of storytelling, but the thing I like about stories is that in the telling of a story, it keeps the author's voice intact. So the way that I tell a story is going to be different from the way that you tell a story, which will be different from the way that you tell a story and you tell a story. We could be conveying exactly the same information, but my method of doing that and your method of doing that will be very different. Just because I'm drawing on my own things, the things I think are funny, and my own experiences, and my own metaphors, and the conversations that I've had with friends, and the books that I've read, and you'll be doing the same thing with your version, and those experiences and things that you've got to reference are different. And so it will be different. So I'm sure we all have that friend that just tells amazing stories, and he's sitting there like, what happened to you? And I'm like, oh boy, hang on, and everyone's like, all right, we're getting a seat, we got the popcorn, all right, go. And that's also practice. That person has worked on, whether consciously or not, a way of telling stories that engages the people that they're listening to. And the thing that I find particularly valuable about this is that everyone's voice is unique. And so while there's sometimes this sense of like, well, why should I write because someone else has already written it? It's like, well, write it because it's your voice. It's not going to be the same as anyone else's. It's going to sound like you. And it will not sound like everyone else. So in my particular case, your voice can sound like so many different things. In my particular case, I found that in addition to wanting to write informally, I also particularly enjoy writing in a way that my editor has called whimsically. I enjoy the silliness. I wanted to have it sound like I was having fun. I wanted it to reflect the fun I was having in learning new things, and I wanted it to sound like I was having fun on top of that. I didn't want to be in a position where I had learned something really neat and cool, and then I was going to have to filter out the like, isn't this cool? Because that was the fun bit. And I didn't want to get to a point where I was writing down like, here is a new interesting fact. Like, yep. Actually, what I wanted to be like, that's weird. Isn't this cool? We learned a whole weird thing. And in the process, I've decided that I absolutely don't mind making myself look silly in the process. So that's fine. And in fact, in most of my classes, I make a deal with my students that at the start of class, we sit there and we go, okay, here's the deal. You can ask me any question you like. I promise not to laugh at any question you ask, and I'm going to ask that you promise not to laugh at each other's questions. In exchange, you're super allowed to laugh at me, because the power dynamics there are totally fair. So I don't mind feeling like people think I'm silly. That's okay with me. That's my decision personally. Like, I want to write silly stuff, and I don't mind people reading my silly stuff and being like, this is a silly human. Like, yeah, that's fine. That's okay. That's an exchange I'm willing to make. So here is an example of what it looked like in practice for the book. So one of the things that I wanted to write about was that I knew that the moon had had volcanic activity in the past. This is a base fact that we learn about the moon. We go, yes, the moon has bright patches and dark patches. The dark patches are called mare, and they used to be lava. Cool. So I had a goal, which was to write about this for a general audience, explaining how we know that and what that would have been like. What did volcanoes on the moon look like? Could we have seen it from Earth? Was it like, was that whole mare, was that just like an open lava pit at some point? Was that not that? Was it something else? I don't know. So the problem I ran into very immediately, as my now protagonist in my own situation here, is that I didn't know either of those things. I had no idea how we knew how much volcanism there had been on the moon, and I also had no idea what that would have looked like. What I had was NASA had given me some visualizations of what the lunar history had looked like, and it had given me some preconceived notions, but I didn't actually know what that looked like. So, to the technical papers. My step one here is I was going to have to find and read a whole bunch of papers on lunar volcanism. And in the end, I cited 9 in the 4 or 5 pages that this section covered. I read a lot more than that, but the 9 that I collected were the ones that seemed most critical to my own understanding. The step 2 that I do, this is my personal method of writing. So I write down a version of events that makes sense to me with the citations that I'm using. So I'm citing the sources that I have, but I'm really not writing to anyone else. The audience for this is just me. This is a way for me to communicate with myself to understand, like, hey, do I actually understand this? Let me see if I can write this down in my own words, but just to me. I'm not trying to write to anyone else yet. This is just for my own understanding. My third step is that I'm going to let all of this information simmer, basically back burner it for a while I think about the most fun way to explain this is. So this is often like a, what kind of metaphors is going to be helpful for explaining this? What kind of things could I attach this to? What kind of jokes can I make that are still technically valid? What kind of science can I play on here? What kind of lived experience might we share that would be helpful? The problem with step 3 is that I have no idea how long that takes. Sometimes, pretty much as soon as I finish writing for myself, I go, oh yeah, I know how I want to write this, and I can just immediately start. And sometimes I write down a version of things and go, this is hard. Yeah, I don't know how to explain this. And then I just have to let it sit and do something else for a while, and it'll come to me eventually. But it can take a few weeks for me to just go, yeah, oh, there's an idea. But I might spend a solid 2 weeks just like, I don't know about this one. Step 4 is that I write a new version of the text. In this case, I am now writing for my audience. So this is me writing for other people. This is me now saying, okay, I've figured out how I want to do this. I figured out what my explanations are. I figured out what my metaphors are. I figured out what my jokes are, roughly. I figured out where the jokes are. Now I can write down the version that is actually going to be considered an actual first draft. From here, there's edits, and at some point I'll just get sick of it and send it to my editor, and then he does his own work on editing it. But this is the process that I go through before I send it off to anybody else. So for the case of lunar volcanoes, what I learned was that lunar volcanoes were pretty explosive. And part of this is because the magma in the lunar volcanism rose from the core or the mantle of the moon up towards the surface really quickly. And so as it rises quickly, the dissolved gases that hang out in that magma will boil out of solution. So we have the same problems if you are trying to depressurize anything. If you can open things, depressurize something slowly, it will just, the gases can stay in solution. The most unpleasant version of this is the bends. If you're a scuba diver, if you rise too quickly, then gases come out of your blood. It's really bad. So this was basically, it's doing that. It's rising so quickly that the gas is boiling out. It's not able to stay in the magma. And so you wind up with this like foam at the top where all the bubbles rise towards the surface faster than the rest of the magma. And so then you reach, we're going to zoom in, we've reached this point where it's actually going to breach the surface. And so when it breaches the surface, there's also just no air pressure at the surface of the moon. So on Earth, if there's a bubble, we have some pressure from the inside of that bubble, but then there's also air pressure pushing down. And so the bubble will burst, but it's not going to burst incredibly explosively necessarily, because what it will do is just pop. But if you're on the moon, there's actually a vacuum, so that bubble is going to burst very, very explosively. There's really nothing to resist it expanding, and so it will just pop, but like violently. So then there's this really fun diagram that I found. So this is my clip art version, but you'll notice this is not actually all that far off from the technical version. So here we have some source region at the bottom, and then you go through the crust and you have boiling and acceleration. This is the boiling out of the gas as it comes out of solution. And then you have this explosive rocket launching happening around where the magma has reached the surface and becomes lava. So things to notice is that we have a lot of rocks being flung in the air. That's basically anything that happens to be dragged out with the bursting of your bubble in your lava. So it's going to fling some bits of magma out, and this will just cool in the air, and it will get thrown at some point to some distance. And we know that this is true because we also have tiny glass beads all over the moon. And particularly these were retrieved during the Apollo missions. So this is an image taken by the Apollo 17 astronauts. And the thing to note here is that the ground there is really, really orange. And so this is actually volcanic material that is discovered on the surface of the moon. So we saw, and so that's what they were seeing here, is orange soil is this glass bead material and other volcanic material. And so we knew that there were glass beads. This is a piece of our information about how this volcanism existed on the moon as quite explosive. Just as a side note, because I found this funny when I was putting this talk together, the Apollo astronauts found a lot of these glass beads, but they also were pretty excited about it. So this is a transcript of the Apollo 17 moonwalk, where we have Schmidt, who is the only geologist we ever sent to the moon, and then his teammate there, Gene Cernan. So Schmidt goes, "It's all over, orange, and don't move until I see it." I started up with my feet, like, "Hey, it is, I can see from here. It's orange. Wait a minute, let me put my visor up. It's still orange. Sure it is, crazy. Orange!" And so this image of these Apollo astronauts just being there like, orange, is so funny to me. It's like, yeah, this is a story already. We now have figured out, okay, here's a little bit about the moon. We have found glass beads on the moon. And in the process, we had some people who are professionals. These are, like, Cernan is a test pilot. That's how he became an astronaut. A geologist can be a nerd, we forgive that. They're geologists, we're scientists, we're nerds. They're pretty excited about it. And so we also have this, from a few minutes later, this quote of like, how can there be orange soil on the moon? Jack, that's really orange. Like, yeah, because we see the moon all the time, it's gray. We got to the moon, it was gray. And all of a sudden there's orange soil. Yeah, that's weird. And so they were duly really surprised and very excited about it. So now I have to explain in my writing, exploding lava and tiny glass beads going all over the place. And so this is where I have to now sit, let this sit for a while, because exploding gases are not the easiest thing to explain. It's a rapid depressurization. That's not particularly helpful for me to say if I'm trying to communicate to people without a science background. And it's both similar to and very different from volcanoes on Earth. And so we do have fire fountains. I think this doesn't have sound, and if it does, I apologize. Here's a fire fountain from the Kilauea volcano. It's in 2018. This is a mild fire fountain. It's large. That's a tree on the side. Don't go near it. It's flinging lava into the air. This is a very, not the most extreme example I can find of a fire fountain on Earth. That honor probably goes to one of the Icelandic volcanoes, which which had something like a 400-meter fire fountain. It was ridiculous, but I couldn't find good footage of that, and I could find good footage of this one. In either case, those are going to be mild fire fountains compared to what's going on the moon. And so I think people will quite happily say, okay, well, draw a volcano. And be like, okay, well, you got the tall peak, and then you got lava coming down the side, and maybe it's like throwing a couple of things around. And that's both helpful and not helpful in this instance, because on the one hand, it's this general sense of what a volcano is, but on the other hand, what's happening on the moon is so much more extreme than that, that I'm going to have to take that understanding of what a volcano is and just drag it much more into the direction of like, yeah, but dial that up all the way in every direction. So what I came up with was this interpretation of here's how to explain lunar volcanoes, which is that, in fact, that the way the volcanoes erupted on the moon had all the grace and nearly the same mechanism of a shaken soda can, except instead of abruptly dousing the surroundings with sticky sugar water, you're going to have a seething foam of lava. Which is true. This is an accurate analogy. If you open a can of soda, you're going to rapidly depressurize the inside of the can. The gas that it was inside that can is going to come out. And if you have done this after shaking it, it's going to rapidly depressurize. And so you're going to foam out, and it's going to overflow and become a big mess, and everyone around is going to go and make sad noises at you. So this is a thing that we learn. Okay, what was it like? Okay, cool. We've got what was it like out of the volcanoes, but then there was a bit more that I was curious about. And so other things that I learned were that because this was coming up so rapidly, the magma that reached the surface of the moon usually emptied itself out in 3 to 4 days, which is a lot faster than a lot of volcanic eruptions on Earth. But that was typical. In extremes, you can have some of these run for about 4 months. And if they're running for 4 months, they can leave behind basically a drained lava riverbed. And these are seen on the moon now as a sinuous rill. So that's what this is. It looks like a little river. And it also, your brain wants it to be like big out, but it is actually a divot in. And what this is probably due to is just a really long lava flow where lava was fountaining out of the surface at some point at the end of this. And then the lava basically made itself into a river and went down, whichever direction that was. So often it went down into another crater, or it just took a winding journey across the surface. And these then could take a little bit longer because you have to fuel this for some time in order to get this far. Also learned that there were a lot of eruptions. You're somewhere looking at with a range of 30,000 to 100,000 eruptions. And this means that we don't actually think that everything was filled all at once. We're looking at a whole bunch of consecutive eruptions that each built on each other and gradually made the moon into what it is now. Rather than what I had been misled by massive visualization, which is that it was a boiling pit of lava at some point inside the mare. What actually happened was we gradually filled that with a whole pile of consecutive eruptions. So in this section, the fun thing about writing books is you can also write footnote jokes. And so in here, I had a footnote that was sitting there being like, well, how do we know there's so many different eruptions? One of the ways that we know this is by looking at craters that have punched through one layer of lava and revealed a chemically distinct layer below. Just like punching your fist into a cake will reveal how deep the frosting layer is and whether or not the cake is chocolate. That's fine. That's a completely accurate sentence. If you punch your hand into chocolate, you will find out how deep the frosting is, and you will figure out what the inside of the cake is made of. This is a silly sentence, but it's not a bad one. And it does give you the sense of like, okay, well, if I have 2 layers of lava and they came out at very different times, they're going to be made of slightly different materials. And so if I want to know how many layers there are to that, yeah, punch a hole through it. See if that works. Do you see something different underneath? Or do you have 3 kilometers deep of the same lava? Then that starts to tell you, is this a 1,000-layer cake, or is this a big pile of the same thing? So this is obviously a goofy thing to say, but that's fine because I've already agreed with myself that I don't mind being goofy. And also, this was a super fun sentence to write. I actually forgot that I put that in there until I was checking numbers for this, and then I looked at this footnote and I went, yeah, my editor really let me do that. That actually went all the way to press. No one stopped me. And having that sense of like, ooh, I got away with that, is kind of fun in and of itself to look back and be like, yeah, no one stopped me from doing that. That made it, that's in a published book now. And cited. Because I can cite the sources that tell me, oh yeah, that's how our volcanoes, this is part of how we know that our volcanoes were doing many layers instead of one giant eruption. So I do a little bit of the storytelling in all my science communication now, including talks, as you will have noticed at this point, and especially if you were at the bullet lecture. I do a lot of this kind of, okay, well here's a story and here's a problem, and then we have a puzzle, and so then we're going to try and figure something out, and how do we solve that puzzle, and then, okay, now we've figured something out. And I've done it twice already in this talk. That structure has been replicated twice. In a talk, generally, when you are listening to someone explain their own research, usually they spend a lot of time talking about why they're interested in the thing that they're studying. And then they'll spend a little bit of time talking about how they tackled the problem. Not so much on what the problems were, but like, how do I want to approach this thing that I don't understand? And then they'll spend some time talking about what they found and what does it mean. This is a totally normal, zero problems approach. But for my purposes, wherein I don't mind looking silly, I have decided that if time permits, which it does not always, sometimes you have 5 or 10 minutes to explain your science, and then you really do just have to give as direct a message as you can. But if time permits, it's much funnier to me to talk about some of the problems. This does 2 things, in my opinion. One is that it humanizes the process of doing research. Because I am a human, I make mistakes, I do things wrong, and my science does not run smoothly. Because I am a human and I do things wrong sometimes. And 2, it allows me to build in some of these challenges of like, and then I had a problem, and then I can overcome that problem. And it takes people with me a little bit easier because now I'm storytelling instead of just being like, I'm going to information dump at you. So humanizing the process looks a bit like this. Because we're all taught in school that there is a scientific method, and the scientific method is have an unanswered question, form hypothesis, design experiment, test hypothesis, summarize results of test, confirm or alter hypothesis, repeat. That is the scientific method as it is taught in schools. And so if I were to take this structure and apply it to my research, it would look like, I do not understand galaxies very well. I will sit at my computer. I will make numbers happen. I will then interpret those numbers. I will then write the paper, talk about the paper, and repeat with the next thing I do not understand about galaxies. But in actual fact, this is a gross idealization of the process, and the actual process tends to look like, sit at computer. Make some numbers happen. Numbers make no sense. Try something else. Make more numbers happen. Kernel panic my entire computer. Morgue my CPU while I stare at the screen for the 13th time. And then remember the importance of optimizing my code, which I didn't do up until this point because I was feeling lazy. Then I get annoyed at myself and optimize my code so that I don't keep kernel panicking my computer because it doesn't like it when it runs out of space to keep the operating system going. Then I will get confused because something else doesn't make any sense. And then I should probably talk to some other people about it because I'm not making any progress on my own. And someone else will ask some questions or think about it in a different way that I will find helpful. Then I can go sit back down at my computer, make some brand new numbers happen. Oh, the numbers are starting to make sense. This is good. All right, I'm going to start writing a paper. I'm going to rerun absolutely everything I've run up until this point because the figures aren't right. And I would like it to look nicer now this time, please. Also, I'll probably have to restructure my code because one of these programs takes 3 hours to run, and I don't want to keep running that every time I need to regenerate a figure with a slightly different font size. I'm going to change my interpretation at this point because something else showed up that I didn't anticipate, and I think I understand things better. Now I can write. Then I can wait for the referee's opinion on what I've written. Then I will make even more numbers happen because the referee has asked me to check on some things that I haven't checked on yet, so I will have to sit down and make those things happen. Then I can make changes to my manuscript and resubmit it, and at that point I can exhale deeply and have a snack. And that's actually what it looks like. Note, the snack is not optional. The snack is self-care, and that's important in here too. So if I'm actually telling any part of that story means that when I'm talking to students and I'm giving talks, this is like, hey, yeah, I know that you're having problems. Everyone's having problems. This is not a problem-free endeavor. Absolutely 100% of scientists have not solved the problem on their first try. This isn't just, that's how it goes. In my case, it's very messy. But someone else's, it's not going to be exactly those steps. They might not kernel panic the computer as much as I do, but it will be a similar flow. And so everyone is having these problems. It also sets up, in my case, an astronomer versus herself story, which is kind of fun to talk about because then I have this battle with myself where I'm trying to understand something, and the problem is in between the keyboard and the chair, and so my code is not doing what I thought I was telling it to do, and I then have to overcome that problem as well. And so then when I get to the end of, I understood it, that's a lot more satisfying because I've been fighting to get to that understanding, both against myself and both against numbers that haven't made any sense, and the universe's general disinclination to do anything in a sensible fashion, then I can get to that conclusion of like, I think I've figured something out. And that is then quite satisfying. And it helps explain why we bother going through those 4 pages of steps, because at the end is actually satisfying. And at the end I want to do it again because I just learned something brand new about the universe that no one else knew before. And now I get to tell other people about it. So in general, my philosophy is basically this XKCD comic, where it's, I try not to make fun of people for admitting they don't know things, because for each thing everyone knows by the time they're adults. Every day there are on average 10,000 people in the US hearing about it for the first time. If I make fun of people, I train them not to tell me when they have those moments, and I miss out on all the fun. And so, if I get to communicate my science in a way that invites those questions, then I get to have all the fun of explaining it to them in a way that I also find fun. And then everybody's having fun because they're learning something, I get to explain something I find cool. So in principle, astronomy is a field that we're in because it's fun to know things about outer space. It's not a field that is nearly as lucrative as a lot of other fields. It's not a field that we can really do outside of academia, but we're in academia generally because we like knowing things about outer space, and we like being able to figure out more things about outer space. So when I am writing, it became important to me that I be able to get that sense of fun across when I am talking about it, because it's not something that is dry and tedious. This is a thing I'm doing because I genuinely want to know how galaxies work, and I think it's cool that I get to do that. And so I can then talk about it in a way, it's like, yeah, why am I doing this? I'm doing it because it's cool. It happens to also pay me, but, and I wouldn't do it if it didn't pay me, but the fact that I do get to do this and it does pay me is great. And I find this quite fun. And anyways, I'd rather make footnote jokes than be a serious professional all the time. And so this is where I've landed. I find this way of writing really fun. And I have continued writing books because I find it really fun, and not because this is a lucrative side gig. It is not. It is a huge amount of time and effort, but it is the form of writing that I find most entertaining, and it is not the technical paper. So this is a volunteer, this is a thing that I've decided to spend my time on because I find it fun, and not because it is a requirement of my job. And every time I do write another book, my skill with writing, that piece of the technical knowledge and skill, my skill with writing gets better. And so that means that the thing that I have written is more exactly like what I wanted it to be, and the gap between what I aspire to be able to write and what I can write shrinks. Also, writing books is basically the only place I get to make footnote jokes. You can kind of do it on slides. It's not quite the same. And so the footnote jokes are good, and they're very satisfying to be able to write, especially when your editor doesn't get rid of any of them. It's just like, yes. So I'm going to stop and tell you that the storytelling model that I have found is an extremely functional framework for taking science results and presenting them in a more accessible fashion. And by accessible here, I just mean understandable to someone who does not have the skill or technical knowledge of reading the technical paper for themselves. So it does open up this understanding to more people in a way that I think is a good thing. It leaves a lot of room for the author's voice to come through. And since everyone's voice is unique, it leaves a lot of space for many people to do speaking and for many people to contribute, even on the same topic, because everyone's version of telling the story will be different, and it will appeal to different people, and your audience will be slightly different based on who you are and your experiences and how your writing and the things that you specifically find fun come across. It does require technical knowledge, which comes from our professional training, and it comes from skill, which comes from practice. And so both of those things are things that are achievable. If you desire the technical knowledge, then you can get that through your undergraduate or graduate training or postdoctoral training or wherever you are in your scientific program. And the skill just comes from practice. And so if you're willing to set aside the time to practice and think about it and try again and be kind of bad at it for a while, then the skill will also occur. But the number one thing I think is just the advice is to have fun with it. If it's not fun, don't bother. If it is fun, then keep going. And you can use your own sense of fun to drive what direction you want to go in. And so, I'll take any questions if there are any.
I just want to say something really good.
Oh.
I taught high school English for 45 years.
Yes.
I know a lot about writing, but I was always really frustrated when we had to write research papers, and research papers had to do with this list of things that you got for research papers, and they were all serious. And I modified it for my kids because I wanted them to enjoy writing and write about something they liked and write about something they wanted to do. And that made it divided from all the technical stuff we get over and over. I mean, it can go as far as the Shakespeare stuff that's hard reading, or it can go back to their chemistry book, their math book, all those things that they just hate. I offered to my stepson, when he finished freshman algebra, that we could take the book and burn it.
Yes.
You know, that was how much he hated it, because we worked together on learning it to be sure he had it and could go in science if he wanted to.
Yeah.
But, you know, that he could do it. But I've always felt like so much writing is made difficult for regular people that could read it if it was regular writing, that would enjoy if it had some jokes in it or some comparisons between something that was funny. So kudos to you.
Thank you. That is where I am aiming. It's like, this is for people who are curious, but for whom this information may never have been accessible before.
So you mentioned coding.
Yeah.
I was just wondering how that relates to astronomy.
Oh, that's how I do all of my science. I have a huge database of information, and the way that I sift through it is through programming. So right now I have a database of something like 1.5 million data points. I'm not looking at all of those myself. And so I need to get the computer to sort through them for me. And so I need to write programs that sift through that data for me and allow me to spot patterns if there are any, and rule out patterns if there aren't any, and then for me to interpret those patterns and things that I see or don't see in some physical way. But the programming is really there to help me not have to do everything myself. So it's there, I tell the computer what to do, but from there it's really a case of like, okay, well, I'm not looking at all of that data. How do I summarize it? Because I don't even want to plot 1.5 million points. That'll also crash my computer. So how do I summarize this data in a way that is reasonable? What's a subset of this data that might be interesting? And all of that is programming. Yeah.
One more question.
Sure.
So the database that you mentioned, like, do those like come from testing, or are those like already like done in like public databases?
They're publicly available data. So this is a portion of the Sloan Digital Sky Survey, and they have as part of their funding model that they release data products every year just freely to the whole community. And so some people have worked with those just as the data that comes down from the telescope, and other people have worked to help extract more information out of that. But if they're working as part of the Sloan team, that information is also publicly released. So then I take that publicly available information and I work within that to develop new things that weren't part of that release, and then to understand those things that I'm able to create. So.
Two things.
Yeah.
One, thank you very much. That was a fantastic job. I don't think I've ever had anyone hold my attention for that long.
Thank you.
You're welcome. So here's my question. Do you think that you can still optimize your method of translating information from the technical writings into stories? Do you think you're always like trying to find a better way to do your process of translating it?
I think my goals change over time.
Okay.
So the kinds of stories that I change over time, the kinds of stories that I wanted to tell have changed over time. So I think with my first book, I was really just trying for clarity.
Right.
And so my goal was, how clear can I make this concept? And this most recent book, I was actually trying for funny. And that felt very, way more risky, because humor is so individual, and I know that my humor is not going to be everyone's humor. And so sending that away felt like, what if they don't like it? Because it's a perfectly reasonable response to ridiculous jokes. Like, not everyone is going to look at, let's punch a cake and think, yeah, that's a reasonable metaphor. But I thought it was funny, and so that's why I went in. And I think as I keep going, that's what's going to change. So the type of thing I'm trying to convey is going to change, but I'm following fun in both cases. So even when I was just aiming for clarity, I was aiming for clarity without sacrificing informality. And so now that I know that I can do clarity, it's like, okay, well now I can be clear and I can do this other thing simultaneously. And so I think what will change is my sense of what can be achieved and what I want to achieve. And so yes, I do think there's room for expansion, but it is very much based on what was the things that I found most fun about the last thing that I wrote, and what could I do next? Because the first book did have footnote jokes in it. And then when I was pitching this most recent book, it's like, yeah, so you remember those footnote jokes? What if I wrote a whole book that was just that? And so going forward, I think that's what I'll just build on myself and see how it turns out. But I don't know exactly which direction that's going to go.
Thank you.
Yeah.
I have a question, but I was waiting until the whole audience is done asking. And that's because of the second one, which is the unique voice.
Yes.
So when it's a professor kind of question, but it's like, when I have students write their thing, I want to, whenever it goes into the journal, I want to keep as close to what they wrote compared to. So it's like, all right, I'll fix spelling. I have this issue as well if I'm a referee. Not everybody's a native English speaker, so this comes across as sometimes a little harder to read. And so, if I'm editing for clarity, am I editing for clarity, or I'm basically making everybody's voice conform? And
Yeah,
not
and
every Shakespeare.
I think the
is the
voice,
same, right?
the more formal the genre, the less voice is apparent. And so, but that's not to say that, I think if someone read my papers, they would still be able to hear it, because I'm the one writing it. But I do think that in general, the formality of the language required for a technical paper, and because we are writing functionally to other experts, rather than to someone who does not have the background, the density of material that's there does require some conciseness, and that does slightly tamp down the level to which your voice can be heard. It's still present though.
I was trying to figure out, like, 'cause that's the thing that, well, I would say that especially people who are not native English speakers will run into, because the formality is also very strict.
Yeah, it's quite rigid.
And so you get really common things like, your sentence structure makes no sense. It's like, yeah, it's Germanic, and which means that it is technically correct English, and no spelling checker is going to catch you on it. You just sound like a psychopath to an English speaker.
Right.
And so you get comments that are incredibly vague, like the English is bad, and you're like, well, where is it bad? Like, can you mark up where the issue is? But not, and so it gets dismissed as well. So there's lots of conflicts of like, I don't understand, like, I understand the sentence, it was not an issue, you just think the English is bad, and therefore the science is bad. And so how do you avoid that if you turn to storytelling? Because storytelling, like grass writing is storytelling.
Yeah.
And that's a storytelling competition before anything else. So yeah, thank you, this will help. But yeah, how do you keep the student's voice in there and not edit it to death?
So I think there's a big space here between, so the way that I approach it generally is, I guess there's three pieces to it. One is I'm checking on exactly who we are writing for. And so if we are writing also for non-native English speakers who are going to be reading the paper, then as much clarity and precision in language is helpful. So that's one piece of it. And in other cases, it may not matter so much. If it's an honors thesis and it's being read by a group of people that I know, then some pieces of imprecise language is probably fine. The second piece of it is that the thing that I always try and keep in mind is that there's a difference between giving constructive feedback and trying to make the paper the one that you would have written. And so as long as it is clear, it doesn't have to be written in the way that you would have written it yourself, but if it says the thing that it needs to say in a way that would not be confusing, then that's okay.
Yeah, I continue to agree on that, and I get like a referee paper by a Spanish-speaking person, for example, and there's often a sentence where I'm kind of going, where are you going? And yeah, so I know there's examples of clarity,
Yeah,
there's examples of voice, and I'm like trying to make sure that I don't stray into the other way, because
Well, I think a good example is potentially these quotes that I gave you, because this is extreme voice, but without losing clarity.
right.
And so I could also write something that had no voice and was very unclear. And we probably could go to the archive and find a whole bunch of examples of that.
I'm sure that's
There is, I think most people wind up somewhere in the middle. And I think for technical papers, you generally wind up in the hyper clarity side of things, or that's more the aim. But this, I think, is a good example of like, okay, yeah, you can have a lot of voice, author's voice happening, but we haven't lost any clarity here. It's a very specific metaphor, and I wouldn't put this in a paper, in a technical paper, but I put it in a blog. And I think it's, for going through a very technical topic, it's kept the clarity. So I do see them as slightly different concepts. One is it clear what you're trying to say? And the other is how you say it in terms of like where are you coming from? And so you could come from a very weird place, but say it with perfect clarity. And that would be voice, but not a clarity issue. Whereas if I don't understand a sentence and I have to reread it 3 times, that's a clarity problem.
Yeah, that's how hard it gets. It's
Yeah.
the kind of thing like, I do feel like, even for technical papers, the storytelling can matter. I know many of the papers like, this was a great paper and I was just going to nod them along. And it's because the storytelling was good.
Yeah.
And so I feel like there is something you can take from storytelling and take it to reading. It's almost like you have, everybody knows what Hamlet is, but every Hamlet production is a little different. Because it's who's in there, how they approach various things. The text is still the same. So it's like you can play with the formal things. More constrained, but you can play with it.
There's definitely a little bit of play that is still available within the technical paper. And I think part of the reason I went this direction was because it was much easier for me to depart from that entirely in order to play extremely with it. And so it has bled back into my paper writing, I'm sure. But I think if I had tried to do it within the confines of paper writing to start from, I would have struggled a lot more to find this kind of writing. And this I'm finding very fun. So I think I would be sorry to not have tried it.
Right. Where you go? Yeah.
I'm sorry, I was a bit late and I didn't get all the things, but I don't know if we discussed it or not. But the thing is, like when we approach like scientific papers and all those things, we have like certain linguistic approach to it. Like we specify and use specific terminology to explain specific thing, and we have like built quite a lot of vocabulary for that, like for our scientific terminology to specify all those things. But when you like write something for general audience to understand, we have to like avoid those like technicalities, like those terminologies to become more like available to the public. But there's that risk, right, to like the lost in translation, like what I'm saying.
I think so.
Yeah, that technical thing is like is prone to being misinterpreted, or
So I think it's not required that you lose all of the jargon. And like even in my talk yesterday, I used the term stellar remnants. We talked about white dwarfs and black holes and the core of a star and fusion and all of these things and hydrocarbons. And that's not necessarily, like at face value, not necessarily accessible to the general public. But because of the way I explained them, I was then able to use those terms. So I explained what a hydrocarbon was, and I spent a little while there. And then I could say, okay, well, this one's a hydrocarbon too, because it's also made of the same materials. And so I think there's a balance to be held, and trying to avoid technical language completely is really hard. To the point of being unhelpful at some points. And so sometimes you do need the technical term, either for simplicity in your wording, or just for clarity grammatically. And in those cases, I think you can get away with it. You just can't keep things being too dense in your writing. Because if you start throwing too much new language at someone, they're going to feel lost. But if you judiciously need to introduce like 2 or 3 terms that are going to really help you to be able to talk about it, either grammatically or clarity-wise, then you can do that. You just have to be really careful about how you introduce those terms and how you explain them. And then once you have that done, you can then proceed onwards and be like, yeah, okay, this is fine.
Because an ongoing problem that I really see is that Bob Science website and all those things, it really dilutes like all the elements to a very basic thing that doesn't mean anything.
Well, I think that very much is dependent on the author.
Yeah.
And what the author's goal is. And so with for some authors, the goal is for them to feel smart. And for some authors, the goal is to explain something to someone else, and they have someone in mind. And for other authors, it's, like in my case, I think it's just to have fun and to see how much fun I can have while still being clear. But I think some people do, there are some cases where people can try to explain something in such simple language that it stops meaning something. And this is a little bit what happened with the Upgoer 5 kind of book, where we have Randall Munroe's attempt to explain a rocket with the 5,000 most commonly used words in the English language. It really doesn't mean anything, except that we know the words that he's talking around. And so, but if you didn't know the words that he was talking around, that book would be incomprehensible.
Exactly.
And
That's the
so,
part.
well, so this is the point, is that sometimes the words are helpful. You just, I would not spend a whole book explaining how a rocket works. Personally, that would not be fun to me. But I can explain how a rocket works generally with silly language. But I may still need to use the word thrust. But would I define that? Yeah, absolutely. Can I still talk about rocket fuel? Yeah, that's fine. Do I need to talk about ammonium perchlorate? Probably not. Can I? Yeah. Depends on how I introduce the topic. So I think it really depends on what you're doing, who you are, what your goals are. And I don't think that using technical language is really verboten so much as it is a thing that you have to be aware that you're doing so that you can define your terms carefully.
I sort of do this when I talk about data visualization. So we talk about graphics. Like, who's your audience? What's your medium? It's like you throw a graphic onto a screen presentation. It's very different if you do it on a website, because then you can zoom in on the website. Or is it on a paper? Is it on a poster? Who's this for? And Kurt Vonnegut had a great one, like pity the reader. And it's like I just go like pity the audience. It's like to figure out what kind of visual you use. Like this is what sort of the storytelling goes visual as well.
Yep. Yeah, which is why I have these kinds of things. Yeah.
Okay. Thank you so much for giving the talk. I really enjoyed it, and I think the audience did too. So
All right.